Section 6.4.2 Vectors and Dot Products. This video is about projection vector and work-related problems. Projection of U onto V. Let U and V be non-zero vectors. Then the projection of U onto V is given by this. Projection U onto V is U dot V over square of magnitude of vector V times vector V. Finding the projection of U onto V. Example 1. Find the projection of U onto V, then write the U as a sum of two vectors, one of which is projection of U onto V. So here we have a vector U angle bracket 2 comma 2 angle bracket, vector V angle bracket 6 comma 1 angle bracket. So let's first find a W1 projection of U onto V, whose formula is U dot V over square of the magnitude of V times vector V. Now we substitute U as the angle bracket 2 comma 2 angle bracket, and V equals to angle bracket 6 comma 1 angle bracket. So this becomes angle bracket 2 comma 2 angle bracket times angle bracket 6 comma 1 angle bracket divided by the square of magnitude of angle bracket 6 comma 1 angle bracket times angle bracket 6 comma 1 angle bracket. Now we simplify. Here we do dot product. So 2 times 6 is 12, and this 2 times 1 is 2. And on the bottom, you square the 6, square the 1, take the square root, and then square it. Multiply the vector angle bracket 6 comma 1 angle bracket. Now 12 plus 2 becomes 14, and 6 squared is 36 plus 1 squared is 1, 37. Square root of 37 is 37. So times angle bracket 6 comma 1 angle bracket. Now we multiply or distribute. So 14 times 6 is 84 divided by 37 comma 14 times 1 over 37. So that's the W1 projection of U onto V. So once we get the projection of U onto V, angle bracket 84 over 37 comma 14 over 37 angle bracket, then we have to find W2, and W2 is vector U minus W1. So U was given angle bracket 2 comma angle bracket 2, and W1 we have found 84 over 37 comma 14 over 37 with angle brackets. So now we substitute this vector here and this vector here. So we have a angle bracket 2 comma 2 angle bracket minus angle bracket 84 over 37 comma 14 over 37 angle bracket. Now we subtract the first components, 2 minus 84 over 37 comma, then subtract the second component from 2, there will be 2 minus 14 over 37. Now in order to subtract, LCD is 37, so we convert 2 into 74 over 37. In other words, multiply 2 with 37 and divide by 37. So now they have same number. Similarly, multiply 2 with 37 and divide by 37, and this will become 74 over 37 minus 14 over 37. Now we can subtract 74 minus 84 is minus 10 over 37 comma 74 minus 14, there will be 60 over 37. So that's the W2 vector. Definition of work. The work W done in moving the particle from point P to point Q by a constant force F is given by this formula, W equal to F times PQ, or W is equal to the magnitude of F, force F, and the vector PQ times the magnitude of vector PQ times the cosine of the angle between force F and the vector PQ. Example 2. Work. Determine the work in moving a particle from point P to Q when the magnitude and direction of the force are given by V. So we are given point P 1, 3 and point Q -3, 5, and the force is given by vector V equals to -2i plus 3j. So step 1, we find vector PQ. So vector PQ we'll find by subtracting the, this is initial point, this is terminal point. The coordinates of initial point from the terminal point. So we'll say -3, subtract 1, multiply the unit vector I, plus subtract from 5, 3, so 5 minus 3, multiply unit vector j. So this simplifies to -4i, and this simplifies to 2j. Now the formula for the work is the force multiplied dot product with a PQ, vector PQ. Now we substitute F is equal to V, and to become V dot vector PQ. Now we replace V, this force vector, minus 2i plus 3j dot vector PQ we just found, minus 4i plus 2j. Now we take the dot product and you just multiply the -2 with the -4, ignore the I, then multiply 3 with 2, ignore the j's. So you have a -2 times -4 plus 3 times 2. -2 times -4 is 8, and 3 times is 6. 8 plus 6 is 14. So this is the 14 is the work. Example 3. Determine the work done by a person lifting a 245 Newton bag of sugar 3 meters. So the distance to the force is 245 newtons and the distance 3 meters. So the magnitude of the force is 245 and the vector PQ is 3 and the angle theta is 0. So the formula is W is equal to magnitude of force F times the distance vector PQ times cosine theta. Now the magnitude of force F is given 245 and the magnitude of vector PQ is 3 and the angle theta is 0. So this becomes 245 times 3 times cosine 0. Cosine 0 is 1 from the unit circle. So you have a 245 times 3 times 1, which you multiply gives you 735 newtons meter. Example 4. A constant force of 50 pounds exerted at an angle of 25 degrees with the horizontal is required to slide a desk across a floor. Determine the work done in sliding the desk 15 feet. So here the magnitude of the force is 50 pounds. And the distance vector is PQ is 15 feet and theta and the angle is 25 degrees, and the formula for the work is the magnitude of force applied times the distance vector PQ times the cosine of the angle between this force applied and the distance vector. So now we substitute the magnitude of force F is 50 pounds and the magnitude of vector PQ 15 feet and the angle theta is 25 degrees. So this becomes 50 times 15 times cosine 25. Now you have to put in the calculator and in degree mode, so you should try to get 679.7 pounds.